Welcome to our next session. Lutz Huehnken is going to tell us how to keep our event-driven architecture sane with events, workflows, sagas. Let's learn how.
Hopefully, yeah. Hi, welcome to my talk about this. So before I start the talk, I start the talk now, but at the beginning of my talk, I want to start with a little anecdote, and that goes back to 2008. In 2008, I think it was Springer actually. Axel Springer announced that they would move to Apple computers for the whole company. Like they would become the biggest Apple customer in Germany, quite interestingly. And then there was a press release about it, and they said, we're going to move to Apple and so on. And if you read the whole press release, at some small paragraph in the bottom, it read that these machines would run Windows XP or Windows Vista. This was, of course, 2008. It was time of Intel Macs. They didn't have the Apple Silicon then. So that's maybe not insane, but that seemed really odd to me. That's like, why would you use or why would you buy all this Apple hardware and not leverage the benefits from it by just putting Windows on top of it? So now I'm talking about putting workflows on top of event-driven architecture. I'll leave it to you to see if there's any connection to the story or not. So what are we talking about? Not about Apple computers or Windows. We're talking about event-driven architecture, event-driven microservices, right? So the setting you got to imagine is you want to build microservices, you want to build a new system, so you do some research, you dig and you see, okay, events is all the rage. Everybody says if you want to build a scalable microservices that can, whatever. Super resilient and so on, then you build it based on events, right? You don't build call cascades, you don't build a distributed monolith, you build event-driven microservices. So let's look at a super simple example. This is actually a very common example if you sort of look for, stuff in the internet. Sooner or later you come across an example like this. This says nothing about the quality of this, and this is not a recommended implementation, but it helps us to illustrate some points. In this case, this is kind of a hello world for a workflow, right? Because what they implemented here is we have an order process, and the semantics are that in this order, we only deliver when we have, or we only accept orders when we have items in stock, and then the customer has to pay for them, and then we deliver. So two conditions have to be met. We have to check the inventory and see if there's something in stock. This has to be met, and the payment has to arrive. So the process is basically top-down. We get the order in here in the order service. It emits an event. An order-created event. So somebody's going to listen to this event. In this case, I'm just reusing this example, so don't blame me for this. It's the shipping service has the inventory. It confirms the inventory. The order service emits another event. Then the payment service emits an event, and so on. At some point, it's shipped. As I said, what we see here is a kind of a very simple workflow, right? So there are a lot of things odd about this, but one thing I want to point out is what we do here is we're using this order service. This order service has a bit of a special role, right? It's sort of everything goes back and forth to the order service. You could say the order service here is sort of a coordinator, right? The order service knows the overall flow and makes sure that the conditions that are in this flow are fulfilled. It will emit the appropriate events and then sort of proceed this, will progress this as the events come in. Now, this might not be what you want, right? This kind of puts a lot of technical stuff into the order service. It might have to deal with timeouts and also sort of process changes now will affect the order service. Maybe they shouldn't. Maybe it just accept the orders and then move on from there. So one thing you could do is sort of extract this workflow stuff, right? You could say, okay, instead of implicitly modeling my workflow in one of my services, which should be like a peer among equals among the other services, instead of doing this, I'm going to pull out the workflow and make this explicit and use some sort of workflow engine for this. And if you look for workflow engines, you'll find about a dozen. There's the Cloud Native Computing Foundation defines workflows that are then, I think, described in YAML, and Google Workflows, I think, implements this. There's Temporal I/O, which is currently popular, which uses some scripting language to describe the workflows. I'm not even 100% sure about the syntax, maybe JavaScript or so. Camunda, I think, uses a BPMN, like some XML stuff. So you can define your workflow in there. And then you take this out of your order service. Right now your order service just Oh yeah, basically the process owns the order and it creates the order and then checks the inventory, payment, and it's the same workflow basically. So you could do this, and by this you sort of have a nice division between the order service and the workflow as such. Now if you look, we're still in this phase of sort of figuring out how you do it. Right. So also when you look for things, you will probably come across the saga pattern. So very fashionable among microservice people. It's basically, it gives you an all or nothing in a distributed system, right? The idea is that we said we have two conditions that have to be met, the payment and the inventory. So the idea is that the saga is completed when both conditions are met, or if one of the conditions is not met, it will do a compensating action. It's really, it's not different from using workflows or your own service. It's just a pattern in this, right? But it's so popular and people come across this so often, I thought it's worth mentioning it. So the idea is you start the saga, you have some sort of saga coordinator. This can be the workflow engine or, again, roll your own and so on. That somehow initiates the payment. And in parallel, these doesn't have to be sequential, right? This is part of the pattern. You don't have to do one after the other. You kind of start both. And if one fails, you have to do something with the other, right? You have to do it. It's also called compensating transaction pattern, which is actually a better name. So it's really about for each action that you do in your process, you have a compensating action. And if something in your process fails, you can go back to all the other steps that you've already executed and do the compensating action. And by this, sort of return to the initial state. You could say this is kind of a spiritual successor of distributed transactions, right? It sort of gives you this all or nothing, but it accepts sort of temporary inconsistencies. But in the end, when the saga is either completed or failed, you should be back to a consistent state. So, keeping your event-driven architecture sane. Now, we looked at already, in these 3 minutes or so, we already looked at 3 different things, right? We looked at using one of your services, sort of dedicate one of your services to the process, right? To implement a workflow on top of a couple of services, you could take one of the services and implement a process in this one. Or you could sort of extract this and use a workflow engine and sort of have a nice separation between the workflow and your business logic, possibly. And you can also implement a saga. And you can actually use either of the previously mentioned techniques for this. You can do this in sort of your own and your own service, or all the workflow tools I mentioned also support these semantics, and you can implement sagas in this. So, quiz question: what do all these have in common? What do you think? What do you think of those approaches? Any opinions on this? Any similarities? It's all, yeah. I would put it differently. I would say they all suck. They're all terrible. We started off wanting to do something event-driven, right? And we ended up with some complex technology, and I'm going to dive into all these points a bit later. So I'm a bit biased against workflow engines and so on. I guess you haven't caught this yet, so I'm going to sort of argue against these. It's a complex piece of software I'm going to introduce there. It also sort of dilutes some clarity about responsibilities, and it's actually not event-driven, which is how we started. So what about the complexity of the software? So, well, if you look at the saga, for example, that's a process. This process can have many steps, and of course, your saga coordinator needs to keep track of where this process is and of the compensating actions. It has to persist them because it might crash, and it has to do this in some sort of distributed way because, well, it might crash even worse, and the server might not come back up, so it must be started somewhere else. Also, you don't want it to be a single point of failure, right? This is true for all of these, for the workflow engine, or for your own service. So you need to distribute it. And it's stateful, right? It has to keep track of where your process is at. So you need some distributed persistence to make sure this works out, or even some sort of coordination between your instances. People use Paxos, rafts, and so on to actually do this. So this is, a lot of things can go wrong there. This is why, well, you will often hear the advice to not implement this on your own. So the first pattern we looked at, do your own service that takes care of the workflow. A lot of people will advise against that because you have to take care of all this. You have to deal with timeouts. You have to deal with timeouts after your workflow engine crashed and comes back up. So you also have to persist where you are in the timeouts. And again, in a distributed way. So you don't want the timeouts in your cluster. You have to. It's really. I wouldn't want to implement it. I admire people who do this. If you use one of these workflow engines, then you don't have to implement it because they have their own languages to describe the workflow. But then that's that. Right now you have some of your logic in some XML file, which is great for unit testing, excellent. And or YAML for God's sake, for the Google workflow engine, right? Because that works so great with Helm and Kubernetes, and it's so, nobody ever gets anything wrong there. So this can get really messy and can really sort of put a big load on your process. Also, I think something that's really underrated is that, and I'm going to talk a bit more, I guess, later when we talk about a different approach, is the organizational clarity. Right now, you have this workflow calling out to the other services. And where does responsibility lie? How much of the business logic is in the workflow? How much is in the process? If something goes wrong, now you always have these two ends to consider. So first of all, you probably have difficult negotiations about all the kinds of error message your service has to return so the workflow engine can manage it properly. And then something does go wrong. Now, what state are you in? Is this something that is expected to go wrong and the workflow should actually handle it and fall back on some alternative? Or it's something that should actually work and the service has to deal with it? So usually you have multiple parties involved in even finding out what went wrong and multiple parties involved in developing and deploying some fixes and so on. So, oh yeah, and the third point in my list was, and it's not even event-driven. I should have said, okay, sorry about that. This is a really bad slide because it uses these arrows. The semantics for these arrows are, this is actually supposed to be a message, right? It uses, say, Kafka, because that's what people use. And these are just messages on Kafka, an order created message, a ready for shipment message. So technically, these are events. But in terms of being event-driven, this is a really bad design, right? Because an event is supposed to state a fact, okay, that we do. The order is created, it's ready for shipment. But in this case, it's really a message to a specific different service, right? We don't just emit the event for others to pick up and then go our way. We actually wait for some response to it. Order created, what's his name? Allard Boyce, I think is his name, from Exxon. He calls these kinds of events passive-aggressive events. It's like, and his example is, that's a bit old school, but it's not mine, it's his. His example is, you come home and you say, baby, I'm home. And what you really say is, or maybe my girlfriend comes home and my girlfriend says, oh, baby, I'm home. What she really says, it's make me a tea, or like, I don't know, comfort me. So actually it's a command. She just rephrases it as an event. And this is really the same thing here. What we really say is, shipping service, reserve the inventory and give me then acknowledge that you did so, right? It's not an event where we don't care who listens to this event or where we don't care what happens afterwards. It's just, it's just a different way of communicating a command. And that's not good design, because that leads to this sort of request-response kind of patterns, which is actually, well, this is kind of embedded in the workflow, right? I think the workflow is the problem, because, well, we had the idea of implementing our system in sort of disjoint, nice services, and now somebody comes with this requirement and says, oh, on top of your services, by the way, you have to implement this workflow, which obviously spans multiple services. And I think this is really the problem. The problem is not the different techniques, that they are bad, or maybe how we design the events, but the original problem is we accept this workflow. So if you have the situation, if you want to build event-driven microservices and somebody presents you with this, I think you have to decide which way do you want to go. Right? You could say, okay, I accept this workflow, we have to implement this workflow, so we have to put some layer on top of some orchestration layer, maybe on top of our services to implement this workflow, or use some workflow engine. Or you say no. Well, you say, no, this is not, I'm not going to do this. No can do. We challenge this workflow, and we say, no, this is not how we work, right? And this is, I think this is one of the sort of the mindset problems that we're facing. Often, the first answer is that the one we get, or that people come to because of familiarity. They come from a monolithic world, from a very enterprisey world, or from an ESB world, and now facing microservices, they say, okay, challenged with this, how do we implement this workflow, they fall back to what they know and say, oh yeah, let's, in the ESB world, we had this, we could route and transform and do this and that. Why don't we do this? We sort of introduce some layer on top of our services, super nice. And what they don't do is actually challenge it and say, well, this doesn't match anymore. In a sort of monolithic world or in an ESB world, it makes sense. We can have these workflows. But now, when we really want to have autonomous teams that develop their own products as independent services, then this doesn't fit in. We have to take the workflow and we have to break the workflow down. And this is, I think, a term that has only recently come up for this to discuss this better, is micro-workflows. When we build micro-services and look at our workflows, we also have to break down our workflows into micro-workflows. And this brings us back to being event-driven. So our initial goal was to develop event-driven microservices. So why did we even want to do that? Or what's so nice about being event-driven? And how is that so different from this request response, which I'm just going to show once again? I thought I can go back here, yeah. So I think this is very typical in these workflow situations, that the process is owned by the workflow, right? And the process ends here. That means an outgoing, even if it's an asynchronous message, it doesn't really matter here if it's an HTTP call or gRPC call or a message. If the underlying pattern is request response, then the original process will just go on, right? It will go on, it will wait for some response and then move on. This is sort of a typical scenario we see in any workflow, because the idea of the workflow is to be a process, to describe a process among many steps, across many steps. What are events, though, in contrast? You probably heard this many times. I didn't make a slide for this because it's so well known in the domain-driven design community that we usually, in communication between services, we distinguish between commands, queries, and events. Right? Commands are express an intent. I want you to do something, and this can fail. Maybe the service can't do this. And it's I usually expect a response, right? At least an acknowledgement. Okay, I have done what you asked, right? An HTTP call is a good use or sort of a good pattern for a command. I say post blah 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 blah. And I get back, I don't know, created or something 200 and shouldn't have brought this example. Can't remember the status code. With events, it's different, right? Oh, and queries, of course, are just queries, right? I ask something, I expect data as the response. And events express facts, right? An event, if I emit an event, it means something has happened, a fact has been created. An order has been created. So if I submit to this event, there's no point in sort of validating it or challenging it, right? It just describes a fact. So an event is a fact, so there's no going back. Like in a command, I can return an error code and say, no, I can't execute this. With an event, I'm just caught with this. I'm just stuck with this event. I have to do something with this event. It's my responsibility now to deal with this event. But on the other hand, well, that's the beauty. Oh, I'm going to take this away. This might be a bit intimidating. Oh, and it's my responsibility to deal with an event. Other than a command, I cannot just reject it. But on the other hand, once I'm done with what I'm doing, I just emit another event, and I'm done. Nobody's going to come back to me about this event, right? This is just a fact. I don't even care who picks up this event. In a real event-driven architecture, when you pick up an event and there's something, you have some issue with it, you'll never go back to the emitter of the event, right? And even more, if you emit an event, you're never interested in what the subscribers of these events do. You're not even, well, this is at runtime, right? When you build the system, when you design it, of course, you want to talk to the people who subscribe to events, and you have to design it, and you have to send meaningful data, and so on. But at runtime, you don't even care who picks up the event. And this is, well, obviously, why would you wait for some response? You don't even know how many people would possibly respond to it. And on the other hand, or not on the other hand, but in addition to this, if you can't handle the event, it's your problem, right? The responsibility is super clear here. And notably, which you will see if you look, for example, at actors, which people use to build high availability systems and so on, you distinguish between the client of some service, or in this case, somebody who emitted the event, and some sort of supervision, right? So if I call a service with a command, I get something back, then I also have to deal with the error. Right? So I have both roles there. I'm the client, or like in programming. If I call some Go function, I get back the result or the error code. So I'm both the sort of the consumer, the client of this function, but I also have to deal with the error handling. In asynchronous systems, like in active systems, where you just send messages, this is like fire and forget. And if an error occurs, somebody else has to take care of it, usually some sort of supervisor. Also in our case, this is something when you build event-driven services, it's obviously something you need to be aware of. Well, we can come back to this later. Oh yeah, what would it look like if it was event-driven? So this is obviously a super simple example. Well, the big difference is we don't have these request-response types anymore, right? We don't have this do something and then I get the result and move on. There's no coordination anymore. So a little additional thing I applied is if a prerequisite for creating the order or for dealing with the order is that inventory is there, then we should move the data to where the decision is made, right? So we would send events also to the order service so the order service has the inventory data and can check if it can accept the order. So the order service would create the order and then it's done. Nothing's ever going to come back to the order service, right? Nobody's going to report back to the order service. For the order service, it's really just an order acceptance service. It has accepted the order and it's done. Of course, the same with the payment. It will initiate the payment and then it's done. It doesn't care what happens afterwards, and the same here. Shipping service, maybe somebody else picks up this event. Yeah, bring the data to the behavior. This is also, if you in your workflow, there's a query stage. I think that's already a smell, right? If you sort of have to reach out to some other service to get some data, we should push the data to where the decisions are made, right? Data, what's his name, Angelo? He posted it once on Twitter, right? Like data can travel across bounded context. For behavior, that's not so desirable. Now, of course, you have a lot of people that are very skeptical of this. And they would say, oh, yeah, but the end-to-end process. What about the visibility from end to end? And, you know, the customer, they want this. So don't mix this up. Don't mix control and observability, right? These have actually they're not necessarily connected. And if we don't have to connect things, we should keep them separate, right? Keep things simple, focus on one thing. Don't make them complex, dealing with different things. Control, you usually want to distribute, right? As an example, Temporal.io, I mentioned it, they also sort of offer end-to-end visibility about how your workflow goes, but that's a sort of completely separate subsystem. The actual workflows can be handled by different machines on different nodes, but you need to aggregate the data, or you want to aggregate the data to query it. So they put in an Elasticsearch server and basically push events to Elasticsearch and observe it there. And of course, well, you can build your own order status service that will subscribe to all of these events. And then you have the overview of the overall status there, right? So control and observability don't have to be mixed, and so we shouldn't mix them. Oh, and workflow people love timeouts. They're all like, oh, everybody on the front page will mention, oh, you can deal with timeouts, and you don't have to worry about time. Apparently, timeouts are a huge thing. I wonder what people actually do with these timeouts. Like when I've seen cases where people sort of use timeouts basically for monitoring if the service is actually even there. Like if they get a lot of timeouts and it's probably not running, or there's something like misconfigured, or they adjust the timeouts and make them bigger, because if it's actually about response times, they just sort of increase the timeout so they still get the responses. But of course there are different uses for timeouts. Maybe it's about flaky connections, right? You sort of you access a different service and in the cloud, and across availability zones and so on. Sometimes things are just not there, so you want to retry with some backup and so on. This is really something that should happen within your service, right? These kind of connections, there should be a domain service that handles this, that deals with this. I think the sort of reacting to this and doing this should not be, you can even do this with infrastructure, right? You can probably use your service mesh or whatever to deal with this. It should not be in these sort of more businessy workflow. Processing times, if you want to sort of detect timeouts, we have this in container logistics. Sometimes you book sort of ongoing transport, right? The container will arrive at some port, and you have to commission somebody to pick it up. And the time is sometimes essential there. You need some feedback, otherwise you kind of escalate or do it manually or whatever. So people want to track, but that's really a bit about service levels and promises. it's a bad workaround for a service not scaling. If you just emit your events, as I said, it's the responsibility of the service processing the events to pick it up and to process it. And this can be connected to response times as well. And this, of course, puts the responsibility on the service to scale, but this is something we can do technically, right? We need to watch the consumer lag. We need to see if there are events waiting to be processed, and then we need to scale up. So it's really the service that does the work that should have the proper promises and the proper service level and capability to do this. Or you could still, of course, do some observations over the process and can connect this to alerting as well and things like this, right? So if you really need this for whatever reason, you always have the option to introduce some sort of service that will just sort of also consume the events and maybe raise some alerts if it's waiting for something that's not happening and so on. So it's not that great a feature, I think. It's definitely something you can deal with. Oh, error handling. Yeah, again, errors should be handled within a service, right? So this is really, in this event-driven world, well, I'm repeating myself though, it's the responsibility of the service. And this is so important. I already explained it, so maybe I should have explained it with this slide and not earlier, but it's a very fundamental idea in event-driven architecture to separate the data or the sort of the flow of the data from the error handling, and not just sort of having the caller tell the caller this has not worked and let the caller deal with it, but separate this. So that's actually a good thing. Also, in terms of error handling, again, this is much clearer in terms of responsibility, right? This is something I think we all, architecture and organization, that's a huge topic also in this conference, right? How does this relate? Do we need to change our software architecture to support a certain organization? Or what does work well with organizations, with agile product teams, and what doesn't? And this shared responsibility of somebody being responsible of the overall flow, and then errors can happen either there or there, and then they have to align, it's at least not helpful. Now you're going to say, okay, but this is a super trivial example. This is just 2 steps in a super simple workflow. So obviously, this is just, you can talk about this on the slide, but it doesn't work with bigger workflows. I would argue it does, right? But it's really not so accessible on slides. Like this is even in German, sorry for that. I was a bit lazy and I'm not great in BPMN. And this is from a blog post that basically covers the same stuff that I cover here in this talk. And it's only slightly more complex workflow, but has some cancellations in it and so on. But I think it gets difficult to fit on the slide. And if you want to discuss, but this could easily be converted. Oh, should I go back for the picture? This can easily be converted into a more properly event-driven architecture, where here these things that look like databases are actually the events, and the boxes are the services. So it's not all services, not that many. Just showing it's not about the technicalities. This is, if you want to discuss workflows and how to convert them into event-driven, this is maybe a good topic for the open space tomorrow, or for some sort of workshop or whatever. It's not easy to integrate this in sort of a talk with slides. But for now, just let me assure you that these technical issues like timeouts and error handling, they are not the problem. The problem is the mindset of the architects, developers, business people, whatever. That we come into this with this workflow mindset, and we think of this end-to-end process that we somehow have to impose on these. But if we sort of switch this and sort of, instead of, when we start off event-driven, instead of going back and saying, okay, this is sort of, I don't really know how to do this workflow thing, so I go back and take a sort of very sequential monolithic approach, go deeper. Think about the fundamentals. Think about promises, for example, promise theory. I'm not big on promise theory, but I know it exists. And a big idea about this is that these are different approaches of how to manage things. Right? You can command people, you can sort of divide and conquer. You can say, this is my process, I command you to do this, and I command you to do this. Or you can work with promises. And you can say, okay, I don't care how you do it, but these are the events you need to process. I need you to handle the payment stuff, and then emit an event when it's done. Right? And then sort of put the responsibility in this service. If we use this as the bottom-up approach, and if we think about what promises do we rely on, what promises do people need to fulfill so the overall process will work, that's a completely different way of looking at it, obviously, and gives a lot of organizational clarity as well. So I'm just, because it's a mindset thing, now I'm going to have a couple of slides where I just talk about sentiments, and it's difficult to convey, so I try to produce some examples that hopefully one of them maybe you can relate to. Unix philosophy. Everybody loves the Unix command line, right? And how does it work? You pipe something into a command, and it will just read from standard in and produce something to standard out. It will never care about who consumes this stream in this case, right? If I do a set, grep, org, something, they don't even know about the other commands. So they consume something from standard in, and then it's their responsibility. Actually, they have two options: produce something to standard out, or to standard error, right? This is kind of their variety of I deal with errors myself. They kind of escalate the error. Somebody has to watch standard error and then react on that. Of course, this is a very simplistic thing, but it's very universal as well. And I really like to think about services in this way. Can I compose services the way I can compose Unix commands? This is the big underlying thought about this. Often we are facing complex problems, and as architects, as consultants, as developers, we think, oh, this is a complex problem, so I'm looking, maybe a complex solution is adequate. Of course, maybe Temporal I/O or Camunda, maybe these are complex tools, but there are complex problems, complex workflows we deal with, so complex problems we have to solve. Do we, though? Often we have a choice. Often we can go either way. We can say, okay, we accept this complexity, and then we maybe come up with very complex solutions, or we challenge it and say, no, my task is not to solve complex problems. This is it, right? My task is not really to solve complex problems. My task is to understand the problem and take it apart, rephrase it, sort of separate, sort of break it down. So in the end, we have small problems that we can solve. Another similar sentiment, maybe obviously unrelated to event-driven architecture and workflows, but maybe for understanding the mindset and sentiment issues I'm getting at. I don't know where you work or if your company does SAFe, but I think a lot of people would agree that these are at odds, right? Actual agile processes and being agile and then implementing SAFe, this doesn't really work well together. It tries to sort of unite the enterprise world with the agile world. And Martin Fowler, as you probably know, says SAFe stands for shitty agile for enterprises, right? And if I compare workflows to SAFe, you can, at least now, I mean, if not yet, now you know I really don't like them, because this is something I think is a terrible thing. So all these have this, or this has this in common, right? That I think the event, well, let's move on. Somebody already said it. You're just talking about orchestration versus choreography, right? And maybe or maybe not. You can also get the slides afterwards, actually. You don't have to take a picture of all of them, I think, or you can get them for me. In a way it is. It's really about orchestration versus choreography. The terms are correct, but I think it's a bad starting point to talk about this, because it has been so commonplace. Now, if people say, it's just orchestration versus choreography, people are already in some camp, right? It's like if you do a talk about orchestration versus choreography, you might as well do a talk about Emacs versus VI, right? It's not really going to be an exchange where people sort of grow and learn something. It's just going to be about the two camps, and people are just going to say, oh, you're a choreography guy. No, I'm an orchestration guy, and that doesn't really help anyone. So I kind of try to avoid this. But really, what I propagate, of course, is choreography. Oh yeah, I think you're going to get your lunch early today, because only 2 slides left. So, summarizing, am I saying workflow tools are useless and are shit? No, of course not. Well, workflows are a useful tool. We use workflows a lot. We have huge workflows across all the company, not even things that are workflows involving actual people and departments and so on, right? And processes that we need to document. Workflows are a useful tool. Workflow engines are probably a useful tool as well for some cases. Just as I said in the beginning, right, Windows is probably, maybe it's not that bad. It's just silly to put it on an Apple computer. So I think in the microservices world, and of course that's how the vendors also position themselves, right? They say, oh yeah, you're doing microservices, you can still use workflows, of course. It's great for orchestrating microservices. I think that's not the case, right? I think if you really want to go microservice, event-driven and so on, then that's a use case that you shouldn't have, right? Having a complex workflow and implementing on top of microservices, that's a use case you shouldn't even have, because you should break down those workflows into micro-workflows. Yeah, consider going sort of all in, consider going event-driven. Now, I probably after the talk, or maybe already in your heads, I'm probably going to get a lot of counter arguments on this, right? I know a lot of people love these. Or maybe if you're open to input, maybe you're going to ask around and ask people for advice. And people are going to give you advice. But I think all of these cases will happen, right? Sometimes I've had a lot of colleagues that were very there was no ill will, but they really knew like the ESB world well, and they felt very comfortable in it. And to go sort of event-driven choreography, for them that was madness. Like, oh my God, nobody's going to know what's going to happen, right? We're going to look at our processes and nobody's going to know where this, for example, in shipment, where is the container? Because, I don't know, somehow, I don't know what they feared there, but they thought as long as everything is sort of in some workflow, well, it's an illusion of control, by the way, but anyway. So if people tell you, hey, just use a workflow engine and use the Saga pattern, is it because they're just familiar with it and this is in their comfort zone? Or is it maybe somebody who sells such a tool again? It's totally legitimate to point out what you can use your tool for and that it can be done with this. Or is it somebody who really understands what you want to achieve, what your vision is, and knows the trade-offs and sort of gives a genuine, honest opinion on it and says, I really think you'd be better off with a workflow engine because what you're trying to do there, I don't know. Right? I think all of these cases will exist and definitely not only this one, right? The third one is probably, that's the one you need to get to, right? So this also exists, I guess, but the first two happen very often. So it's not even about not choosing a certain solution, but not sort of prematurely jumping to solutions, right? Oh, I'm familiar with distributed transactions. Now I'm doing microservices. There's the Saga pattern. That's the solution. I'm just going to use the Saga pattern. Don't, right? Take a step back, think about the foundations, go back to first principles, go back to event-driven principles, and then if in the end you decide, okay, in this particular case, with this legacy system and whatever systems you need to integrate, maybe it's still the right choice. Maybe it is. I don't, only the Sith deal in absolutes, I think they say in Star Wars. So I'm never going to say never, but I'm going to say there's a mismatch there, right? Just with agile and safe and agile and between event-driven architecture and workflow engines, there's a mismatch there. It's not a natural fit, right? So you're creating friction there. And you might be in a position where you cannot leverage the advantages of event-driven architecture because you're not going all the way in, but you're kind of fighting against it, right? Yeah, keep your event-driven architecture sane. That's it already. I'm done.